2025. Astronomers spot Tracy Atlas, just the third interstellar object ever seen, racing into our solar system at impossible speed. But when the James Webb detects a steady, pulsing glow coming from its core, light no simple rock should emit, everything changes. The object's brightness triples expected values with zero comet tail or flicker. Its rotation, clockwork steady. Then comes the shock. Multiple teams confirm a thermal heartbeat pulsing every few hours and a cascade of strange radio signals that match no known natural process. If this is real, it could be the first evidence of something built, not born, heading toward us right now. So, what is Tracy Atlas? And why does its arrival have the world's top scientists demanding answers? August 6th, 2025. Deep in the data stream from the James Webb Space Telescope, a group of NIRSpec operators flagged something that did not add up. The first infrared frames of Tracy Atlas showed a concentrated glow at the object's core, not a scattered haze, not a diffuse coma, just a tight, isolated source bright enough to outshine the surrounding dust. The readings came in clean, with no sign of instrument error or solar flare contamination. On the raw plots, the heat signature stood out. A white-hot core fading into colored bands, all centered on a nucleus no telescope could actually resolve. The Webb team, led by senior instrument scientist Dr. Lena Marowich, checked calibration logs, then ran the numbers again. The emission was steady, holding at levels 3 times higher than any model predicted for an object this size and distance. There was no tail, no flicker, just a fixed, unwavering beacon. The team's internal chat filled with questions. Was this outgassing or something else entirely? Archive checks began immediately. Hubble and TESS, data from earlier in the summer, hinted at an active object, already glowing far beyond the orbit of Jupiter, long before sunlight could trigger normal cometary activity. But nothing in those records matched the clarity or intensity of Webb's new images. For the operators, it was clear this was not a routine discovery. The heat was coming from deep inside, not from the sunlit surface, and whatever was powering it, the usual rules did not apply. The optical survey teams, led by the Atlas Group in Chile, and analysts at Hubble began their own round of checks. Their first concern was brightness. By every standard metric, Tracy Atlas shone at nearly 3 times the intensity expected for a body of its estimated size and distance. Light curve studies plotted over weeks showed a steady, unwavering output. No dips, no surges, no evidence of the flickering usually caused by jets of gas or uneven surfaces. For comparison, typical comets brighten and fade as they tumble, their icy crusts venting in fits and starts. Here, the pattern was almost flat, with a measured rotation period of about 6 hours, enough to reveal any major surface activity, but nothing appeared. Hubble's high-resolution images searched for the classic tail, the streaming plume that signals a comet's ice turning to vapor. Instead, the object was wrapped in a tight, teardrop-shaped cocoon, more a shroud than a tail. Analysts noted that even at 6 astronomical units from the Sun, where sunlight is weak and most comets lie dormant, Tracy Atlas was already active, glowing against the black. No model of solar heating or standard outgassing could explain the intensity or the timing. These contradictions left the optical teams with a puzzle. A body too bright, too steady, and too self-contained to fit any familiar category. The usual comet rules did not apply. For the researchers, the next step was clear. If the light wasn't coming from the surface, perhaps the answer lay deeper inside. Infrared analysts on the Webb team began dissecting the time series data, looking for any sign of pattern in the heat pouring from Tracy Atlas core. What caught their attention was not just the intensity, but its rhythm. Every 4 hours, The central glow swelled and faded in a slow, deliberate cycle. The pulse was unmistakable, steady, almost mechanical, with energy peaking at the heart and radiating outward in waves. No random flicker, no chaotic outburst. The data logs filled with timestamps, each marking a rise and fall that repeated with uncanny precision. Lena Marovich and her group mapped the intervals against the object's rotation and orbital parameters, searching for a natural cause. Nothing lined up. The heat did not track surface features or solar input. It pulsed from deep inside, untouched by the changing angle of sunlight or distance from the sun. To the Webb operators, it looked less like a comet's outgassing and more like the heartbeat of something engineered. Observatories from California to South Africa tuned their rays to Tracy Atlas, searching for any trace of electromagnetic activity beyond the optical and infrared. The Allen Telescope Array, led by Dr. Kavita Ralph, began sifting through hours of wideband data. Filtering out background hiss and satellite spillover, the team isolated something that didn't belong. A faint, narrowband pulsar repeating every 4 hours, unwavering in its rhythm. Fourier analysis confirmed the pattern. A stable carrier cut sharply against the static, with a repetition too precise for random cosmic noise. Over several nights, the pulse held steady, yet its timing drifted in lockstep with changes in the solar wind, matching fluctuations tracked by space weather monitors. Independent teams at Meerkat and Arecibo verified the signal, ruling out local interference and terrestrial sources. The pulse's persistence, its subtle environmental shifts, and its cross-hemisphere replication forced a new question into the open. Was this a natural process or a deliberate transmission from something aware of its surroundings? Mid-August 2025, the anomaly deepened. Webb's live feed caught a sudden flare. Tracy Atlas brightened by nearly 40% in less than an hour. The test satellite, still tracking from Earth orbit, confirmed the spike. Every telescope trained on the object registered the same surge, not just in visible light, but in thermal output. For a brief window, the object radiated as if something inside had powered up. Then, just as quickly, the numbers stabilized, but at a new, elevated baseline. Attention shifted to the orbit. Marco Micheli and the ESA Near-Earth Object team ran updated models. The predicted path calculated from months of data no longer matched reality. Instead of drifting passively, Tracy Atlas veered its trajectory, bending closer to the plane of the solar system. Micheli's group debated the cause. Outgassing, measurement error, or something less familiar. The acceleration didn't fit any known comet behavior. For the first time, the data hinted at a maneuver. With the flare and course change locked together in the logs, the question now pressed harder. What kind of object changes course mid-flight? And why here, at the edge of the ecliptic? August 18, 2025. Webb's NIRSPEC instrument handed the baton to the spectroscopists. Carrie Liss' group at Johns Hopkins took the lead, processing the raw spectra from Tracy Atlas. The usual comet markers, water, ice, carbon dioxide, were present, but layered atop them sat a puzzle. Several absorption lines refused to match any known catalog. The reflectivity profile hinted at metallic alloys, some each showing rare Earth elements found only in advanced manufacturing here on Earth. Buried in the data, a handful of features aligned with theoretical quantum materials, structures described in physics papers, but never observed in nature. For the team, the evidence pointed away from random cosmic chemistry and towards something that looked, at least on paper, engineered. By late August, access to raw telescope feeds began to tighten. Internal memos from NASA and the ESA referenced new data protocols, citing planetary security. The SETI working group, led by an anonymous coordinator, debated whether to transmit a mathematical signal toward Tracy Atlas. After a tense vote, the message was sent. Prime numbers. The prime numbers the periodic table, and basic constants. 72 hours later, a narrowband reply arrived, timed to the second. The return pulse was distorted, but its pattern matched the original transmission window. Agency officials locked down the data, rerouting communications to classified channels. Outside, speculation surged. Inside, the atmosphere shifted from curiosity to something closer to caution. At the August show debate, 4 leading models, outgassing jets, radioorganic heating, dust scattering, and mass estimate errors were tested and found lacking. None could explain the full chain of anomalies. Now, with the September flyby approaching, the countdown is on. Our instrument will be watching, hoping for the data that finally settles the question. On August 6, 2025, the James Webb Space Telescope recorded Tracy Atlas emitting infrared light 3 times brighter than models predicted for its size. Over the following weeks, teams documented a centralized pulsed heat signature, a repeating radio signal, and a sudden 40% flare that coincided with a shift in its trajectory. Facts confirmed by TESS, Hubble, and European Space Agency orbital data. Spectroscopic analysis revealed rare earth alloys and absorption lines unknown in current catalogs. Despite multiple independent reviews, natural explanations such as outgassing, radioactive decay, and dust scattering were all ruled out by the International Astronomical Union debate panel. As of late September 2025, its closest approach is imminent, with major observatories preparing for direct study. What is clear? Tracy Atlas challenges every current model of interstellar objects, and its next passage past Earth will be a decisive moment for planetary science.